Hi, I'm Kyle, and I'm part of the Theory and Computation team for the Air Swimmers. We use CFD software to simulate flow over a flapping fin. We varied shape, frequency, pitching amplitude, and inlet velocity to find the most thrust at the best efficiency.
I'm Alan, and I'm on the experimental team for the Air Swimmers project. Our job has been to perform wind tunnel tests to verify the computational results. On one side of the wind tunnel, we created a mounting system for a servo motor which rotates the fin to create a flapping motion. We use three methods to determine results. We use a fog machine to perform flow visualization. We also use a wake rig to get preliminary numerical results. Our final results were based on data from a force balance. The force balance gave us a combination of thrust and drag forces, and the best results gave us net thrust forces.
Hello, my name is Kira Hine from the Air Swimmer project team. Our job this summer was to modify an air swimmer so that it could run autonomously. We started off by replacing the tail fin motor with a new motor controlled by an Arduino board. That motor is then controlled using a C++ code to make the fish travel around the 6th floor of the Bright building. Since the floor is a basic rectangle, it seemed like a good place to start. The first code we used relied on only conditional statements. However, this made the fish more confusing to code. We altered the program then to use functions that were easier to modify. Originally, we were controlling the distance traveled using sweeps of a tail fin. However, that too was changed so that the fish used a set frequency with changeable angles for a certain amount of time. During our first trial runs with the fin, we found that we had two main problems: too much weight and too little control over the fish's movements. We removed the breadboard and moved to a smaller rechargeable battery to lessen the load, but that still proved to be not enough. While the fish was flying, we also found that air currents from the vents caused the fish to be constantly hitting the walls, thus interfering with the program path. In the fall, we plan on switching the board to a smaller version, and also adding more pieces to help control the fish. We plan on adding a modified pitch control device in order to program the fish to move up and down. Once we have that working, we will be attaching sensors to the fish so that if the fish moves too close to a wall, the code will change the program path to compensate for the air. We are currently working on this code and are looking into how to make the functions run as seamlessly as possible. Thank you for watching.